network. So first it has to understand the whole SMS, WAP push, WAP business, and then it has, of course, to the IP stuff, the WAP post and get. And it has, it has to do a lot of parsing. So it has to parse like the SIML or WML for the presentation part. That's basically like HTML. I will show you a little bit more. And of course, like all the image formats and maybe movies, audio. So there are a lot of possibilities for programmers to make mistakes in all these parsers. So so the actual client, the MMS client, is not written by Microsoft. They just bought it from Arcsoft, small company in the US, which really doesn't care about security. I talked to them; they don't care. Or maybe now they do, but they didn't tell me if they do. So yeah, and the actual application is called Tmail Access. So maybe you want to start your PDA and look if you have like a vulnerable device. I actually only tested 2 different versions, so maybe other versions are vulnerable too, but these versions definitely are. So if we want to attack something or attack the user agent, we first need to see, okay, what kind of inputs does the user agent have? Because inputs equals possible attack vector. And since we have some infrastructure in the backend which handles each message, we really have to look at the infrastructure, because it could do sanitization. Like if you have like some invalid message, like an email, if the email is in the wrong, if the header is there's something wrong, maybe it's rejected. And for MMS it's the same. It looks into some headers and says, oh, maybe no, maybe yes. And so you actually have to like do some testing to actually see what's going on there. And and since we pay money for each MMS, we started implementing like a small virtual MMS infrastructure, so we can do our testing offline without bothering some mobile phone companies' network. And also we save some money, so that's also very fun. And the actual testing, I used fuzzing because no source code available and very fast results. So for the MMS user agent, we have identified the notification. That's the thing that goes over SMS before the actual message is received. Just a very small thing that fits in one SMS, some header fields. Then we actually have the real message, which is delivered via or received via WAP HTTP GET. And then we have the actual message body, which is I took it as a separate part because the encoding is totally different, and as we found out, most MMS providers don't look into the body, so you can just place anything you want into the body. It's also, of course, carried over WAP HTTP GET. So yeah, for the infrastructure, we basically set up a small fuzzer to check what parts of an MMS message are sanitized or validated in any way, because if you find some vulnerability in the phone, but it's in a field that's sanitized, then it's worthless, because if you send it into the infrastructure just discards it. It's useless. So we did some testing, to see that we have so we can just have like a list of good for us parts of the message which we can use. As I said, we just did like very low profile fuzzing because we didn't want to trigger anything at the mobile phone service provider. And as we found, like the message header is heavily sanitized. Most of the fields are not usable for attacks, but the message body is just they don't look at it, just all the headers around. So now to something interesting. The new message notification is, as I said, delivered via WAP-push, via SMS. And SMS also has the notion of ports, basically like TCP/IP. So binary SMS is sent from this port 9200 to port 2948. It's an SMS port. So on the Pocket PC there is the push router. It basically routes different WAP push types to different applications. And if it sees like application MMS message, it just says, okay, MMS client, take it. And the fun thing is, who would have guessed how the client gets to know the URL of the actual MMS message? Yeah, they just send like an URL in the SMS which just says HTTP doppelpunkt whatever, yeah, / and yeah, MMS, normally like something like mobile service provider name .mms or /mms, and then some funky looking number. And that's basically, yeah, they just send you, here is an HTTP URL, get it, it's your MMS. So on the fun thing is, yeah, you can also send this notification over UDP to the same port on the wireless interface. That means you don't need MMS to you don't need an actual infrastructure to do testing. So yeah, so here's a packet dump where you just see the MIME type in the beginning, then the phone number, no, the transaction ID, the phone numbers which are not highlighted, the subject, and the message URL. Yeah, your MMS service provider, and then some ID. That's what your phone gets. Just HTTP get me this. So we can use that to actually attack phones already over wireless LAN. We just say, okay, send this packet to this device, and the phone will say, oh wow, there's a new MMS waiting for me. Let's dial up GPRS. And then it makes also this like ping sound, which is very annoying. Especially if you do it like 1,000 times in a row. And the phone, of course, like starts like eating memory. Then it tries like 3 times for each MMS to receive it. Yeah, you can like fill up the inbox. It's quite fun. And yeah, you have to delete even as, yeah, maybe that's only true for my old devices. On both devices, you had to delete each notification message one by one. So click, delete, click, delete. So it's really not fun to delete more than 1,000 messages. So the fun thing is, yeah, you can send it over broadcast to the broadcast IP address. So yeah, you don't even need to scan for a device or send millions of packets. It's just like one packet, eat. So, and to attack it, you just need to have a unique transaction ID and content location, the URL. So yeah, very easy to build yourself, but I was nice enough to release a proof of concept in August. So yeah, maybe you want to try right now. Maybe somebody is playing with their device online. Yeah. So just a sample screenshot. Your 1,000 unread messages. And of course, the application allows you to like set the sender string and the subject, so you maybe can send some nice message like, hey, update your Pocket PC, or hey, get a personal firewall for your Pocket PC. If there is something like that. So, yeah. So, yeah. Since I use fuzzing, I will very shortly explain fuzzing. As, yeah, maybe somebody was to Gadi's talk in the morning, or so. You basically send halfway valid input, or better, almost valid input to a device in order to find any bugs or exploitable vulnerabilities. And fuzzing really is, or for me really, it turned out to be the best method to do pen testing or vulnerability analysis if you don't have the source code. And yeah, so, but the problem here is you have to pay for each message, or we thought that would be a problem because we want to do fuzzing, and that normally means you really want to use a lot of different inputs, so you have to really send thousands. I guess we I don't know how many, but maybe like millions message. I don't know. It was pretty optimized, so. And you really don't want to pay like 10 cents or maybe even a cent per message. That's like too much. But as I said, we can abuse UDP port thing on Pocket PC to just send our own, to use or build our own virtual MMS infrastructure. So you basically take some web server. I took Apache, a web gateway, and something to generate MMS messages. You can really configure in your Pocket PC phone. You can just say, use a wireless LAN interface for MMS, use this server, use this IP, use this port, and then you can just generate a message, dump it on the Apache server, just send the URL, take the URL and send it via UDP, and your Pocket PC phone will happily go over wireless LAN to your web gateway and say, yeah, get me that URL, and works like it would over GPRS. So we have a very nice way to do the fuzzing, and that's really really a major saved us a lot of hassle. And because in the beginning we thought, yeah, we have to spend a huge amount of money for testing, but in the end we didn't. I think I bought some SMS stuff once to do some other testing, but yeah, we actually didn't pay for one SMS during fuzzing. So yeah, I did actually some very, very brain-dead, low, some very stupid fuzzing. I just looked for basic buffer overflows because I'm lazy and I don't want to do string format stuff. So basically I just say, okay, variable length field, just put a very long string in there. That was almost everything I could find, which is variable length. Then attach the Windows embedded Visual C debugger to the target, and then just send a message. After each UDP message, just gets the message, and hopefully at some point the debugger will say, oh, exception. And if you get the exception, there is it. It's basically like you do fuzzing on your PC, just with a little more stuff involved, like your nice HTTP server, and you actually have to sit in front of the machine because it cannot. I wasn't able to auto-detect if the device somehow freezed, and because sometimes it would respond to pings, and sometimes not, even if it was running or crashed. So yeah, you basically sit in front of your PC, drink some coffee, and press space, next. Worked pretty well. So that's how an MMS message looks. That's transferred from the MMS server to your phone. You have this, in the beginning it's just the binary header again, and then you have some text. The green part is actually just a text file which is included in the MMS, and then you have the SIML file, which is again the HTTP formatting for the message. So it's a multi-part MIME in binary. So as I said, the advantages is if you do testing in your own infrastructure, you can really do deterministic testing, because the phone service provider may be down or may discard your message or do whatever you want, or whatever they want, not whatever I want. So you can really test. You can really also test parts of the messages which should be otherwise sanitized, because maybe you're a good guy and you actually want to find the bugs to fix them instead of just attacking them. So you also want to find the parts that are actually not attackable but would also cause a crash. So you cannot do that in a real environment. And it's faster, like over wireless LAN, there's no delay of the SMS, which could also be delayed by the provider. It's, yeah, I would say like 10 times.